Hi, as you all know, sometime I do some bounty work, so people pay me to do something. I'll be honest, it's really rare, but when I do it, it's because it's something easy. Now it happens that what I have to do for this person is related to one of the lessons I'm doing. We're going to learn a little bit of how to reverse something, and we'll learn how to make an RPC, which is PPC. So, this is Black Ops 2 eboot. We're going to use the PS3 SDK, which, if you follow the tutorial, should be as is in the USR directory. Local, you go and sell. I'm going to teach you guys a little trick here. You go in OS32 bin here, okay? We're going to put the eboot. Move to bin, boom. So, why do we put it here? Let's see. I have two SPRX here and they're useless. Boom. Okay, so a bat file. I have a bat file here. We're gonna edit it. So, boom, boom, boom. Instead of this, encrypts. Rename. This basically make fself. This encrypts an eboot, but we're gonna Control A, Control C. We're gonna do the contrary. We want from eboot bin to eboot elf. Okay. Elf. Okay. And here we want on fself. Okay. Oops. Now you're asking yourself, what is he doing? On fself executable will decrypt the eboot for us. This is the way to do it using the SDK to decrypt and encrypt. So now we want to save this. Do you want to save? Yes, I do. Now, we decrypt our eboot. I hope it worked. Where's our eboot? Eboot elf. So now Black Ops 2 eboot is decrypted. The original. Okay. So, here's how we do. My bad. We're going to use IDA. Of course, we're going to use IDA. Now, unbound user, we need IDA 666. Here it goes. Boom, we're going to take the 64-bit version. Shut the fuck up. It's new. No. Eboot. Okay. So, IDEA will deassemble. It will put, because we cannot go back to C++. The eboot is coded in C++, but it gets compiled in PPC, which is assembler. So basically this is going to give us the source code, but in assembler. So there's no way to get the actual source code unless you hack the company and you get it for free. But you get it for free, but you might get in big troubles. don't do it. Okay, so now we want PS3 elf, okay? PPC. So, boom, this will basically do its job by itself. What it does, it goes through all the bytes and tries to find PPC. And once it finds PPC, it turns it to PPC like here. Okay? So on RPC fast, what it does is it takes all the arguments, okay, sets them to a pointer in memory. And if the pointer is 0, then the register is going to have 0. Register 3 to 10 are the arguments in a function. If you call so basically we call an address if it's not equal to 0, and it just sends the register. So if you have a RTM, so a C++, a C# tool on your PC, and you use CAPI or TMAPI, you could call functions using the RPC. So I'll be back when this loaded. Okay, so we're back. So unfortunately, this is more based on the PPC course, but things you need to know when you do PPC or anything is that I'm no genius. I don't know everything. What you want to do is put the line prefix, because it's super important to know what offset you're at when you do PPC. So in general, line prefix is fucking useful, okay? Afterwards, you would do all this, but I'll cover in my 4th lesson. Now, what are we looking for? For an RPC, it has to be fast. And one of the places where it gets called over and over and over again is FPS, because FPS is frame per second. So you get the frames per second. So that's where we want to code our RPC. You want to go here, go in strings. This will get all the strings in memory that it can find. Now, IDE does not deassemble everything perfectly. So what I would recommend to do is actually run some scripts before doing what I'm doing. I'm skipping steps because this is not how to reverse. Okay, now you want to find a string. So FPS, we're looking for FPS because usually it shows up on the screen, right? So this not it, this not it, this not it, this not it, not it. Oh, this is it. Boom. FPS. Cross-reference. Boom. This is our FPS. So BQ CMPWI. Look, I have no fucking idea what WI is, but CMP clearly stands for compare. And also other things you guys do, you look like when you start, you always look at the code like this. There's no fucking way, and I know PPC. Well, I know a lot of PPC, but not that much. My point is, I get around with PPC, but not like that. Put it in graph, make it easy for yourself. Like this. So this, I know that it's conditioned. So this is basically the equivalent of, let's say, if R3 equals 0, here. So basically, if it's equal to 0, it will jump, which is the green, right? It will skip the FPS. if it's 0. Because what 0 is false usually. So if R3 becomes 1, then it's gonna go straight to the FPS. So however, we have this code can all be replaced, right? This can all be replaced. Now, I'm no genius, okay? I'm no genius, but here's how it works. Pastebin. You go to your pastebin, my pastebin. Okay, pastebin, 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 pastebin. Where's... I don't even remember by heart, okay? But here's the thing. Here's the code ready for compiler, right? This is how it works. This, well, it's all explained here, okay? But we'll go straight to it, okay? At the offset is basically, well, just actually, where can I show you? I'll use this. Good. We'll put a new one. Okay. I'll explain it a little bit, okay? This is actually MW3 FPS RPC that I just keep using. But the point is, you should be able to do your own RPC in another function. If you really want to learn, try to make yourself, you know? This is basically just copy and pasting, but I copy paste all this code because I know how this code works. This code works that at, you see this is, look, 28 lists. So it gets those 4 bytes in, but then this will be like this, okay? 1, 4, okay? So this will be like this. 28 is like this after the first line of code. After, you see 28 is here. So this becomes 48. 12 compares R12 because this goes into R12 because this is read. Here you go, R12. If R12 is equal to 0, then we jump to 74. Now, how does that work? 4, 8, you understand? Like, here we go. We're gonna actually, oops. X74 is 116. And we're gonna divide it by 4. 29. So look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Now 24, so we're at 24, right? Look at this. Wow, that's wrong. X 14, right? Decimal divided by 4 equals 5. 24 plus 5, 20, yeah, 24 plus 5 equal 29. Because in MW3, probably this B there and this BEQ would go to basically here. Actually, here. Past everything, right? But us, we're not gonna do this. Instead, we're just gonna nope everything. We're gonna use it. We're gonna be doing something else. So us, we're gonna do nope, nope. Okay, and this instead, we're gonna do, we said 24, right? We're gonna do 25. 25 times 4, 64. Boom. Okay, now it checks there. If this basically is the offset we want to call in the eboot. If it has something, it will do this. This is basically loading the arguments here. Did I say R3 to R10? Maybe it's R11. Now, this maybe R11 is also an argument. I don't think so. This surprised me. This really surprises me. I'm not sure about this one, but just follow Bad Luck Brian's PDF. But basically, this reads at basically, look, 0, 0, then 0, 4, 0, 8. So it reads all those offsets to check for the arguments. This is float arguments. This is integers or pointers, okay? And this calls R12, which R12 is the offset we want to call. This is move to count register. So R12 goes to count register, and this is jump to count register. And this writes your return. This writes your return. This actually writes what the fuck? Okay, actually, I think there's a little mistake here, because here, what the fuck? There's a mistake in this document, I think. Lucky I reread my code. Okay, so there's missing this. Now let me just see 5 seconds. See, even me, sometimes I have to think. Whoops. So, sometimes I forget stuff. Like I said, I don't know everything by heart. So, like, here we go. Shut the fuck up. Okay, so R3 is first argument, R4 second argument, or others parameters. R is used for syscalls. So there's a little mistake here, and I will correct it in my paste bin. Boom. There shouldn't be R11, okay? And this should be there, because what this does, R4 becomes 0, right? And then it writes 0 to here, where we take our function, because we don't want to call the function 5 times. We want to use it 1 time. So this is really important. See, and so it writes this and this, R3 is the return. It's going to write the return here. And F1 is like a float return, so it would write the float return here. So this code should work. This code, I'm confident it should work. Now, we have 1, 2, 3, 4, 5, 29, right? 29. 29. Yeah, 29. Good. So let's check in IDE. Basically, here's how it works. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now I fucked up, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and we need a 30. So 30 is going to be nope, no operation. So this just skips to the next line. Skips to the next line. So we don't get issues here. Okay. So this is it. Now we got our code, right? Now, because it's been a while, PPC compiler. My PPC compiler, here we go. Okay. Start offset. This should be good. I'm confident in that code. Boom, instruction compiled. Now, how do we get this to an eboot? You want here, take those bytes, okay? We're actually gonna stop this. We're gonna store it just for the sake of it. Okay. So where's my eboot? My eboot here, HXD, put the eboot here, digital fine, right? So let's make sure there's no other find again. There's no other. So here it is, right? Now, I should have noted how many bytes that was, but look, we said 30 times 4. 30, oh, fuck you. It's an X. 30 times, no, decimal. 30 times 4. That's 4, right? 120. So length 100. Wait, it's 120. No, C78X. So we're gonna 78 X decimal. This should be it. Okay. Where is my PPC compiler? So we're gonna Control C here. Boom. See, we calculated this right. So now this should work. We're gonna save. We're gonna remove. Now we want to deassemble the same thing again, okay, because we want to make sure. Shut the fuck up. New. we want to just make sure that our code is written well. Overwrite. Yeah. So PPC, it already knows. Okay, boom, 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 boom. Where we want is here. Go to. Boom. So now we're just gonna wait that it loads. I want to see the graph. What did we say? Option general, you always want the line prefix. So now in memory, you remember how the code was? Now this is how the code is, and this makes absolute sense. So R28, boom, 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 boom. So this should work. This is how you make your own RPC. Now, I'll be totally honest, I did not test this RPC, but I know it's gonna work. I could put my hand in fire, it's gonna work. All you have to do is turn on FPS. So I think it's right here, you turn on the FPS.